Let us learn about serial communications. Computers must be able to communicate with other computers in multiprocessor systems. One of the cost-effective way to communicate is to do serial transmission and serial reception. 8051 has a serial data communication circuit which uses the register SBUF to hold the data. Register SCON controls the data communication and register PCON controls the data rates. Pins RXT and TXT are used for doing data transmission and data reception. SBUF can be considered as two registers, out of which one is used for writing and the other is used to hold the data to be transmitted out of 8051 using the TXT pin. The other is used as read only and holds the data whenever it is receiving the data via the RXT pin. Both the registers use a single address, that is 99H. We will learn about the SCON register. You have the REN bit, receive enable, which is set and reset by the programmer. TB8 bit stores the 8th bit or the 9th bit or the stop bit. RB8 stores the received 8th bit or the 9th bit depending on the mode of transmission. TI is transmit interrupt, which will be set whenever the 8th bit is being or the stop bit in other modes is being completely transmitted, indicating that transmission is completed. RI is receive interrupt, which will be set when the 8th bit is being received or the stop bit is received, indicating that one particular byte is being received completely. It will be reset by the program. RI and TI flags in the SCON SFR is used to detect the interrupt events. If RI is equal to 1, then the byte is received successfully at the RXT pin. If TI is equal to 1, then the byte is transmitted successfully from the TXT pin. So this is the SCON register which we discussed in the previous slide. Bit 7 and bit 6, SM0 and SM1, these two bits decide the serial communication modes. SM2 is reserved. REN, TB8, RB8, TI and RI we have already discussed. So when SM0 and SM1 is 00, it will be used as half duplex mode, synchronous half duplex mode, that is mode 0, where the baud rate will be oscillator frequency divided by 12. It is fixed. It behaves as a 8-bit shift register. When the bits are 0, 1 respectively, it is mode 1, asynchronous full duplex mode. It will be set by timer 1 and it behaves as 8-bit UART. When the bits are 1, 0, it behaves as mode 2, synchronous half duplex mode with the oscillator frequency divided by 64. It behaves as a 9-bit UART, and when both the bits are 1 1, it is mode 3. It behaves as asynchronous full duplex mode. It will be set by the baud rate will be set by timer 1 and it behaves as a 9-bit UART. So power control register is also used in serial communication. The SMOD bit of power control register is used for setting the baud rate. If it is 0, the baud rate is normal. If it is 1, then the baud rate will be doubled. And bit 6, 5, 4 are reserved. Bit 3 and bit 2 are general purpose flag bits. Bit 1 and bit 0 are two bits which shows the power saving modes of 8051. So PD is power down mode and IDL is ideal mode. So serial data communication is relatively a slow process. So we have the data flags which are included in serial control register to help us in efficient data transmission and reception. The flags in the serial control registers, that is TI and RI, are set whenever the byte is successfully transmitted or received. They are all together to produce an interrupt to the program. The program is supposed to read the flags and find what caused the interrupt and then clear the corresponding flag. Data transmission of a serial data begins anytime the data is written into the SBUF. TI will be set to 1 when the data which is stored in the SBUF register is completely transmitted, or when SBUF is empty and another byte has to be sent. If program overwrites the data before TI becomes 1, then the data will be lost. Data reception. Receiving of serial data will begin as soon as REN is equal to 1 in the SCON for all the modes of serial communication. RI is set after the data has been completely received in all the modes. Setting REN is the only direct program control that limits the reception of unexpected data. Reception can be in modes 1, 2, and 3 if RI is set when serial stream of bits begin. RI must be reset by the program before the last bit is received, or else the incoming data will be lost. Incoming data is not transferred to the SBUF until the last data bit has been received, so that previous transmission can be read from SBUF while the new data is being received. There are four serial data transmission modes. Baud rates are determined in the respective modes. The four modes are serial data mode 0, shift register mode, mode 1, the standard UART mode, mode 2, the multiprocessor mode, and mode 3. Setting the bits SM0 and SM1 in the SCON to 00, the SBUF is configured to receive or transmit 8 data bits using the RXT pin for both the functions. Pin TXT will be connected to internal shift frequency pulse source so that to supply shift pulses to external circuits. The shift frequency of the baud rate is fixed at 1 by 12 of the oscillator frequency. When transmitting data is shifted out of TXT, one clock pulse, the rising edge of TXT shift clock. Received data comes in the RXT pin and it should be in sync with the shift clock produced at the TXT pin. When SM0 and SM1 are set to 01, SBUF becomes a 10-bit full duplex receiver cum transmitter which can receive and transmit data at the same time. Pin RXT receives all the data whereas pin TXT transmits all the data. So when data we are telling, there will be one start bit, 8 data bits and one stop bit. Interrupt flag TI is set when all 10 bits have been sent. Each bit interval will be 1 by baud rate frequency and each bit is high or low for that particular interval. Received data is obtained in same order. Data bits are shifted into the receiver at the programmed baud rate and the data will be loaded into SBUF if RI is equal to 0 and SM2 is equal to 0 or else if the stop bit is equal to 1. If 10 bits, start bit will be discarded, 8 data bits will be stored in the SBUF register, stop bit also will be stored in RB8 of SCON register. RI will be set to 1 indicating that a new data byte has been received. If RI is set at the end of the reception, then previous data byte may not be read and new data loaded will be lost. Timer 1 is used for generating the baud rate for mode 1 using the timer overflow flag to determine the baud frequency. Typically, timer 1 is used in mode 2, that is the auto reload mode that generates the baud frequency. F baud is equal to 2 to the power of S mod divided by 32D into oscillator frequency divided by 12 into 256 minus TH1. So you have to load the count into the timer 1 register to get a particular baud rate. If timer 1 is not in mode 2, then F baud will be 2 to the power of S mod divided by 32 into the timer 1 overflow frequency. So let us take an example. If the baud rate is 9600, oscillator frequency is 11.0592 megahertz, then what should be the count loaded into TH1? So TH1 will be 256 minus 2 to the power of S mod into oscillator frequency divided by 32 into 12 into 9600. So we will get S mod as 0 over here. TH1 is equal to 253, which is nothing but FD in hexadecimal. This S mod bit value is considered from the power control register. Serial data mode 2. It is similar to mode 1 except 11 bits are transmitted, a start bit, 9 data bits and a stop bit. Ninth bit will be copied to the TB8 bit in the SCON register during transmission and RB8 bit in the SCON during reception. Both the start and stop bits will be discarded. The baud frequency will be 2 to the power of S mod divided by 64 into the oscillator frequency. Serial data mode 3. It is similar to mode 2 except that the baud rate is determined exactly as in mode 1 using the timer 1 to generate the communication frequencies. So with this we complete the architecture of 8051. Thank you.